Hello everyone. In this video we're going to work on Chapter 2 practice test. I'm going to go through the answers here. Alright, so the very first question asks you to compute the mean for a sample of scores. You could do this by hand, or you're welcome to use Jamovi to do this. You can just enter your scores that I've already entered here into Jamovi. They all go in one column. Right? So I have my scores entered, and then to compute the mean, I click on Exploration Descriptives. Move that variable over. I didn't label it, it's just variable A. And then you can see there that it will give you automatically the mean and standard deviation. So my mean here is 19, sorry, it's my mean. Okay, moving down, the next question asks you to compute the standard deviation for this sample of scores. And so I, again, just look back to my Jamovi output, and I can see that my standard deviation is 9.88. Okay. Now, Jamovi always gives the sample standard deviation. It does not give the population standard deviation. For question 3, we ask you, well, if the data were from a population rather than a sample, what would the standard deviation be? And noting that you don't get this from Jamovi, right? You're just going to have to infer what the right answer is here. And it's going to be very close to the sample standard deviation. And the only value here that's very close is the 9.15. If we were doing this by hand, we would see that for the population standard deviation, we would divide by the n of 7 instead of dividing by n minus 1 of 6 for the sample. Right? All right, number 4, what is the standard deviation a measure of? So the standard deviation is a measure of the typical distance scores are from the mean. Right? It's not the distance between the scores and each other. It doesn't tell us how much variable is due to specific things. It's just telling us the typical amount of variability between the scores and the mean of those scores. Right. For number 5, we're asking you which data set has the largest standard deviation. And you don't need to do any computations here. You just need to look at the data and how spread out they are. So data set A scores range between basically 3 and 9. For data set, which is a range of 6, right? For data set B, scores range between 13 and 26, which is a range of about 13. And data set C, scores go from 3 to 36. Right? So there's clearly way more variability in data set C than there is in the other two data sets. So data set C would have the largest standard deviation. Okay. Next question, number 6, asks about which of the following values can be less than 0. So the sum of the squared deviation scores is the sum of the squared values, so it can never be negative because squared values can't be negative. The mean could be negative, right? You can take the mean of a bunch of negative numbers. Standard deviations cannot be negative, right? You can't end up with a negative standard deviation. You're computing the standard deviation from the sum of the squares, so they won't be negative. X minus m is the distance between a given score and the mean. If a score is below the mean, it will be negative. It's above the mean, it'll be positive. So that you can get a negative score for. And then finally we have the sum of the deviation scores, sum of the x minus m's. Some of the deviation scores cannot be less than 0 because it's always exactly equal to 0. All right, moving on to question 7. This is the same as above. We have a sample of 25 scores and a mean of 75 and a standard deviation of 10. Actually, the only relevant thing here is this. What is the sum of the deviation scores? Deviation scores always add up to 0. And because of that, we square the deviation scores when we're computing the standard deviation. Okay. Question number 8 is asking you to load some data. You're going to have to download and import into Jamovi the Chapter 2 Test 1 data. And this is the vocabulary test scores that we were looking at before. So I'm going to open this up and go to my browse, and I have Chapter 2 Test 1 data. All right, so we're going to compute descriptive statistics by clicking on Exploration and Descriptives, and then moving the vocabulary test over into the variables box. And it's going to give me descriptive statistics here. I have a mean, median, and standard deviation. I can also click below to get the mode to see that as well. Okay. All right. So this, close some stuff here. All right. So this first question is asking us for the mean. Our mean is 6.032 for the vocabulary test. Okay. Next, we want to compute the median. The median in the output here is 6, the middle score in the distribution. And then we have the mode for vocabulary test, which is also 6. So I want to know which measure of central tendency is the most appropriate for these data. So if let's graph the data real quick. We're going to go to plots, and I'm going to get a bar graph because I have discrete data on these scores. All right. So if I look here at my bar graph, I'll look at my bar graph, and you can see that our data are pretty close to normally distributed. Okay. So we have interval ratio data that's pretty close to normally distributed, very, very close. There are no extreme scores or outliers here. And so we're going to use the mean. So you always choose the mean if your data are interval ratio and pretty much normally distributed. Okay, next. The next question is asking about the standard deviation. So we can go back to our Jamovi output, and our standard deviation is right. Our standard deviation here is 2.065. That's the typical distance scores are from that mean of 6.03. All right, moving on. Is the standard deviation produced by your statistical software the sample standard deviation or the population? It's always the sample. Right? So, and the software we're going to use in this class, it will always be the sample. Next, which of the following is the source of variability in the scores? In other words, why don't all the respondents have exactly the same score? Okay. So there are two reasons here. One, there's always a possibility of measurement error, and it's possible that this just isn't a good representation of their knowledge of the vocabulary. Maybe they answered questions wrong. Maybe there's a data entry error. That would be measurement error. Next, we have individual differences. People just have different levels of knowledge or interest or motivation to do this test of vocabulary knowledge. There are no treatment effects because there was no treatment in the study, right? We didn't give different treatments to different groups of people and see how that affected their vocabulary scores. So in this case, it's just individual differences and measurement error contributing to the variability. Okay, next we have each question on the vocabulary test had 5 words, and participants had to indicate which of the 5 words was most similar to the test word. So chance performance would be 2 answers correct out of 10 questions on the vocabulary test. So we're wondering, well, how does our data look when we consider that, right? So our mean was 6.03, right? So our mean was very close to 6 here. So performance was better than chance, right? It was far from perfect, but way better than chance performance. Number 16, suppose that researchers had asked participants to report their annual household income. Which of the following variables would have the most variability? Vocabulary test scores or household income, right? So if you think about vocabulary test scores, they could really only range from 0 to 10, whereas household income can range from 0 into the millions. There's going to be far more variability in people's household income than their vocabulary test scores. Okay, number 17 is asking you to look at a graph and determine if what measure of central tendency is appropriate. So let me scroll back up here, look at this graph. And in this one, we have a measure of introspection, sorry. And this is a positively skewed distribution. Okay? So since we have a positively skewed distribution that is in an interval ratio measure, we would choose to use the median. So interval ratio data, you try to use the mean unless the data are skewed or has outliers, and then you use the median. For question 18, a reviewer determined whether or not job applicants had the necessary experience for a job, just coded as yes or no. So that is nominal data, and with nominal data, we're going to use the mode. Okay. For question number 19, we have a creative work survey measured on an interval ratio scale, and this data are normally distributed pretty much. No extreme scores or outliers. And so we would choose to use the mean. For question 20, we asked people, what is your religion? And we have 3 different categories there. And note that this is nominal data. There's no inherent order here. And so we would use the mode. With nominal data, you always use the mode. Okay, now question 21, a faculty member wonders if time limits on tests increase student stress while taking the exam, and so she randomly assigns her students to take an online exam with a time limit of 1 hour or no time limit at all. At the end of the exam, she asks people to report their perceived stress, and they measure stress on a 100-point interval scale with higher scores indicating greater perceived stress. And she finds that the average scores in the time limit group were 56.43, and in the no time limit group it was 51.26. I want to know what are the possible reasons where there are different scores between these two groups. Well, one possibility is treatment effects, right? These two groups were treated differently. They had different ways of taking the test, either with a time limit or with not. So you expect those treatment effects to create variability. We also have different people in our two groups, which means there are going to be individual differences between the two groups. And there's always a possibility of measurement error. Okay. Now, in question 22, if we look at scores in the time limit group, not everybody in that group had exactly the same score. Now, within that group, there are no treatment effects because everybody received the same treatment. There's no different treatment in that group. So we only have within that group individual differences in measurement error contributing to the variability. Okay. 23 is looking at symbols. Which one is a population standard deviation? The population standard deviation is the Greek little sigma there. The sample standard deviation is the top one, the just abbreviated SD. 24. The SS is an abbreviation for the sum of the squared deviations, or the sum of the squared deviation scores. And then finally, for 25, the number of scores above the mean will always be equal to the number of scores below the mean. That is false. We don't know how many scores are above or below the mean based on that, right? This would be true of the median, right? The number of scores above and below the median would be equal. All right, and so that is all we have for the Chapter 2 practice test. I hope that helped.